Hi, welcome everyone. So we have another live lecture as part of our World Space Week series of activities. So this lecture this evening is given by David Wilkinson, and the subject is all about the physics in science fiction writing. So this is another of our live activities as part of World Space Week. We'll be recording this talk and then posting it on our social media after the event. So if you like it, hopefully you can then share it with all your friends and family and get them involved and interested as well. So if you have any questions throughout the talk, if you just pop them in the questions box and then we'll come to them at the end. But without any further ado, I'll hand over to David to talk about science fiction writing.
Hello, everyone. I guess I should probably start off by saying, who on earth am I to be talking to you about this? So I am actually a physicist originally. I trained in medical physics, but I became a forensic physicist for the UK government. I worked in less lethal weapon systems, then counter-terrorism, counter-drugs technologies, a few other things as well. And then I came to work for the Institute of Physics. I'm the Midlands Regional Manager, but I'm also a visiting fellow at Nottingham Trent University in Science and Technology. And I've also just recently become a senior fellow at the University of Lincoln, where I am going to be helping them out with outreach and things like that. I'm also a science fiction writer. I've had 2 books published, and the first one, and bleed the same, this one here, was shortlisted for the East Midlands Book Award, which is a general prize, which is always a great joy, I think, to find science fiction books in a general prize. So the question I'm asking today, to see or not to see, we'll come back to that at the end. It's kind of a physics pun, so any physicists in the audience will hopefully understand that. And I just want to start off with a disclaimer that all statements, the legal bit, all statements about the works featured in this lecture are personal opinions and take the form of a review of the content and materials. Now, it's important you know that for a couple of reasons. Firstly, this is my opinion. This is my kind of reading tastes. There are so many books out there that anybody, you know, there's far more than I could ever cover. So you're basically taking a look on my bookshelf. And the second is that I looked up the legality of me showing you all the pictures of the books, and I am allowed to do that, as you can see there on the screen. Fair dealing for criticism, review, or quotation is allowed. So I have actually prepared a reading list. So at the end, I will share with the audience the reading list, so you will be able to look up any that I'm talking about during the presentation and find the works for yourself and decide whether you agree with me or disagree with me. So there's a popular view of science fiction, and just to say, I'm going to be entirely talking today about books. So I'm not going to be talking about Star Trek, Star Wars, Doctor Who, anything like. I might do oblique references occasionally, but we are talking about books today. And there's a popular view of science fiction, especially amongst those who think they don't like it, that pulp science fiction is kind of the way ahead. So you've got things like flying saucers. Obviously, flying saucers are all over the 50s, 60s, and so on. And then even more weird and wonderful things like the wonderfully named Planet of the Knobheads by Stanton A. Blent. Interesting works of fiction, very little to do with actual reality of physics and science. So my first science fiction book I ever read when I was a child was Spaceship Medic. That's a lie. The first science fiction book I ever read when I was a child was The Amazing Journey of Spaceship H20. That's by Richard Fowler, and it's this wonderful thing. It's called a pop in the slot book. If you've got some small children in your lives, it's well worth getting hold of this one because they absolutely love it. My children loved it, and my nephew loves it now. So you have this little spaceship. There's 3 people, Chuck, Buzz, and Captain I'll be back later. And they all get in Spaceship H20 and they fly off through the book, and then they can go through these little slots and then end up on the next page in the right place. So they go on this little journey, and what has happened is that some aliens named the Cruels have started to warm up the planet where humanity keeps its frozen food, and they need to go and deal with that. These guys here are the Cruels, and you encounter floating donuts, and they land in a giant hamburger at the end, and it's all a bit silly. So what on earth am I doing talking about this in relation to physics? And the key here is this place they get trapped on halfway through the book called Planet M. M stands for magnetic. And what they are dealing with Planet M is space debris. Now, space debris is a major problem that is only increasing as a problem. We call it orbital debris, so all the kind of stuff that's in orbit around the Earth. And it's any man-made object in an orbit around the Earth which no longer serves a useful function. So there's about 500,000, 500,000 pieces of debris that are the size of a marble or larger. Okay, there are many millions that are so small they cannot be tracked. We do not know what they are, where they are, or how much of it there is. And they travel at speeds of up to 17,500 miles per hour. So this basically means a relatively small piece of orbital debris can damage a satellite or a spacecraft very easily. You know, they have 4 layers of protection around the International Space Center, International Space Station, to try and protect against these little bits of goodness knows what that go crashing into it. In 1996, a French satellite hit and damaged by debris from a French rocket that had exploded a decade earlier. In 2009, a Russian satellite collided with and destroyed a functioning US Iridium commercial satellite. And in 2007, China carried out an anti-satellite test in which a missile destroyed an old weather satellite and broke it into more than 3,000 pieces of debris. So this is an increasing problem, and one that scientists are trying to fix. So there's various different ways of doing so. This graph at the top there, you can see that a bare spacecraft just left to orbitally decay by itself would take about 700 years to land, to enter the atmosphere and burn up. And so you can start to tackle this. If you anticipate that you want the satellite to decay, then you can reduce that to 100 years. You can do other things as well. We're trying to introduce internationally, we're trying to introduce something called the 25-year rule, that no satellite, if it shuts down entirely and the engines stop working, it will take less than 25 years to get down. And so there are various other things they're trying, like an electromagnetic tether, an enormous tether that will use the force generated on it by the Earth's electromagnetic field to slow down the satellite and bring it down into Earth. Gravity gradient tape, trying to do the same thing, but with gravity. Inflatable things. So there's, if you can increase the cross section of the satellite or its density, then even things like space wind and ordinary kind of molecules that you find in space will slow down these objects and bring them back to Earth more quickly. So let's move back on again, back to that Spaceship Medic I was talking about. And I can't remember which of these 2 books was the first one that really got me into science fiction. And it's interesting, the difference between them. So let's start with Wheelie and the Stars. Now, Wheelie and the Stars it was a cracking story. It's about some people where oil has been banned. People are out in the stars, and these people are smuggling in a motorbike because they like motorbikes. And unfortunately, the motorbike shuts down the electrical system, and they have to use the motorbike to go and save the planet. Now, the irritating thing about it is that the replacement energy that they're using is something called rad. And I've drawn you a little circle with rad written in it, because that is about all you ever find out about rad. Okay, it's a universal power source. There is a ball of it on your planet, and you plug into it, from electric toothbrushes to vehicles to everything else, just runs off rad. And that's all they ever tell you. No explanation. Interstellar network, susceptible to electronic interference from motorbikes, apparently, but only from motorbikes. Everything else is shielded correctly. Not sure. So, nice story, great for the age group, which is about 8 to 10 years old, but physics-wise, absolutely abysmal. But let's have a look at Spaceship Medic, which is the other one I read around this time, and I think this is pretty good. It's about a cruise ship that goes to Mars in the future. It's a regular run, but people who want to go to Mars get on this cruise ship. and go there, and it's like, and there's like all kinds of like entertainment on board, because there's a realistic journey time. It takes them weeks and weeks to get to Mars. And halfway, and the point of the story is that it gets hit by an asteroid on the way, and it kills all of the officers. And the only officer who's left, apart from the engineer, is a doctor. And all of a sudden, this doctor, who's only just been to medical school, and it's his first trip, and he has to now take over the ship and solve all these problems that are thrown at him, like solar storms and disease and running out of oxygen and everything else. And he solves them all with science, and it's pretty good, actually. So it has realistic journey time. It's got takes account of acceleration and deceleration. It talks about there being no sound in the vacuum. When two people want to speak to each other in vacuum, they actually have to push their helmets together so that they can actually talk to each other with the vibrations going between them. They have solar storms and how to deal with them. They talk about artificial gravity, which is something I will return to because it's a particular bee in a bonnet I have. They talk about correctional navigation. So the longer you have to wait to make a correction to your course, the more energy you need to do it, essentially. They've got reaction mass versus inertia. So the fact that you actually in space have to throw something away in order to go forwards. Communications delay and transmission. They can't have instantaneous communication with Mars. They have a mathematician as a character and actually solve some of the problems with math. They use electrolysis to solve their oxygen problem. So there's a lot of very good physics in this book. But there's just one thing that really irritated me. So when there's a solar storm coming, this is basically how they describe the shape of the ship. So this point here is where everybody is, and it rotates to create an artificial gravity by the Coriolis effect. So people are stuck to the outside of this as it rotates. And they've got a big water tank here. And normally, so let's imagine that the sun is over here and it's blasting a whole load of radiation out because there's a solar storm. This is the engine, and this is the engine room. Okay, so the engine room is all shielded. And normally, if there's a big solar storm, they rotate the ship so that this enormous water tank here will sit between where all the people are and where the solar storm is coming from, which is an excellent idea. And if you have about 10 meters of water, that will deal with most of the nasty radiation that's coming towards it. Unfortunately, they've lost most of their water. So this isn't going to protect them anymore. So they come up with this idea that they're going to move everybody, all the passengers, into the engine room, and they'll ride it out there. But somebody needs to control the ship and make sure it stays aligned. And so they decide that Dr. Chase, as his name is, can actually, they flood a little washroom with water. And so he can sit in that room next to the control room, use the controls and keep it in. Unfortunately, it's not really taking account of the fact that you need a lot of water to stop radiation. Just a thin, and at one point he's even got a thin film of water in front of his face, and they're thinking, oh, that's just safe enough. You know, there's a load of dangerous radiation in the air above it, and this thin film of water will protect him. That's sadly not the case. You need a lot of water to be able to do that. But I'm not going to slag off the book. I think it's a pretty damn good book, and certainly good for a lot of things. So I was talking about the artificial gravity as well. Now let's have a look at some other artificial gravity, because in films and television, which I said I wasn't going to talk about, but there we go, they often have artificial gravity on ships so that it's cheap to make. It's very expensive and doesn't look good to have people floating around. In more modern films, they've started getting it right by putting people in the vomit comet or green screen or something like that. But in old films like Star Trek, the old Star Wars and stuff, it just would have been so expensive and difficult to have people floating around. So there you go, artificial gravity. And even the great Isaac Asimov didn't do very well with this, as far as I'm concerned. One of his characters says, "This is one of the first ships to be totally graviticized." What does that mean, says another character, but please don't explain if it requires extensive physics. I kind of cried a little bit at that point, especially when he answered, "Anti-gravity is the equivalent of non-inertia. There is no feeling of acceleration when velocity changes, since everything on the ship undergoes the change simultaneously." Yeah, that helps out with things like inertia, and if you suddenly went from 0 to 100 meters per second, you'd splat against the wall or something like that. So yes, that does help with that kind of thing, but he doesn't really explain anything. One book that's much better in dealing with this is one called The Mote in God's Eye by Niven and Purnell. In that one, they take account of the fact that in orbit you would have a rotating ship, and so people could actually use that as the gravity. And then when they start moving around, they stop the rotation and then use constant acceleration. So the constant acceleration of the ship is what will give you the gravity that you experience on the ship. So they'll go halfway to somewhere at 1g acceleration, and then when they get halfway there, they'll flip the ship over and then do 1g deceleration for the rest of the way there. And that way you would still feel the gravity on the ship. Unfortunately, that means that sometimes that's the wall, and sometimes it's the ceiling, and sometimes that's the floor, and so on. So you have to have a whole load of stuff on the ship that so you have a load of stuff on the ship that needs to move around, essentially, and so take account of the fact that you have different things in on different walls. That's the model that's in my own books, and we believe the same is the one that I actually want to go for as well. So constant acceleration is the one that I like. Now I'm going to talk for a moment about good writing versus physics. I've already explored this a bit, that Wheelie in the Stars was an enjoyable book, and sometimes a good book doesn't always marry with good physics, and sometimes good physics does not marry with a good book. I'm going to talk about the Strugatsky brothers for a moment. So there are 3 books that I've read recently by the Strugatsky brothers, Arkady and Boris. One is Hard to be a God. That is set in a pre-Renaissance context and is an example of a science fiction book with no science at all. So humans are on this other planet. We don't explore how they got there, and that planet is in a pre-Renaissance context. So they just ignore the science, essentially. The second one is Roadside Picnic. Now, in this one, it is set on the planet, on Earth, after a visitation by aliens. And the aliens have left a load of technology around, and it's all hanging around there, lying around, and people go out and find this and are making money and trying to figure out what it is. Now, this is an example of one where the science happens off screen, outside of the book. So there is technology, there is science, there is physics, but it is not explored in the book and not explained in the book. But one hopes that the aliens who left it all behind knew what they were doing. And then this third one was actually my favorite of these Strugatsky books that I've read so far, The Doomed City, despite the fact that it does that irritating thing where they kind of go, it may be that I just didn't understand the end of the book, and if anybody's read it or wants to read it and understands the end, I would love to hear from you. I'm not going to say what the end is because you might go off and read it, but it's still a good book and one I enjoy. One thing I find interesting about Russian science fiction and Russian literature in general, if you read any Grossman, Life and Fate or something like that, is the way the Russian people in them speak to each other. It's even though it's translated into English, you can still tell this is a foreign book, and it takes you a while to get your eye on, but it's a really enjoyable way of doing it. So there's another great science fiction trilogy that I've particularly enjoyed recently. It's by Dmitry Glukhovsky. It's the Metro 2033 series. It's set in the future after a nuclear war or an international war, and humanity is now surviving in the Moscow metro system. There's appalling radiation, chemicals, biological weapons. All the structures are still standing. So you wonder, was it a neutron bomb? Was it a load of biological weapons? Have the nuclear weapons, did they get through? Because they would have destroyed the city if they had. And unfortunately, it's a great story, but there's intelligent miasma in it. There's variable radiation exposure consequences. You get metaphysical things. You get these creatures. I'm showing you some creatures that are in it now. That bottom right one is actually known as the Librarian because it lives in the old Moscow library. And so, great book, great story, but I feel he probably wasn't kind of sticking to science. And then the third one came along, which was Metro 2035, and it was like Glukhovsky had suddenly realized that he actually wanted to do proper science. So all of a sudden all the creatures had disappeared, There was a whole explanation as to how the nuclear weapons hadn't got through because of an advanced missile defense system. And they did scientific explanations for everything. The nukes were intercepted. It explains everything, and it really sorts everything out and comes to a really satisfying conclusion, and is the best of the 3 books. Unfortunately, you have to read the first 2 to really enjoy the 3rd one, but I thoroughly recommend this as a little trilogy. So let's talk about Dystopia for a moment. So it's a great part of the science fiction canon, and science is in there. So 1984 is an obvious example. It's a post-nuclear war world. Physics has advanced purely for military and surveillance. New weapons, rockets, torture devices, telescreens. Physics is being turned to evil. A little hat tip, this isn't particularly physics-based, but if you want to see a world that we are blindly advancing into and are so close to, scarily close to, Oryx and Crake by Margaret Atwood is one where you can easily imagine us being there very shortly. Pebble in the Sky is one by Isaac Asimov, where world is living on the edge of radiation. Interestingly, it was written in 1950, and then Asimov issued kind of a retraction or an afterword in 1982, saying that he no longer thought that the physics in the book was valid. So he'd put a load of physics in about radiation exposure and so on, and decided that it wasn't really valid anymore. But he decided, he didn't change it. He just left it out there. Rather obscure one, this one. I'm not sure if anybody would ever have got hold of it, but it's The Reefs of Space, which is part of the Star Child trilogy. Now, this was written back in 1963 and imagined a world where a singularity has come into being, a computer that is running the world. And so you end up in this world where humanity is so crowded that central planning has to be total, and you have full surveillance, and people learn to communicate directly with the computer by singing. And that sounds a bit odd unless some of you are old enough to remember dial-up modems and the and all the rest of it. So that kind of predicts that kind of interaction. Another one by Asimov, The Gods Themselves. This one explores the idea of an inter-universe electron pump. So creatures from different universes have managed to take advantage of the difference in the fundamental laws of each universe to create an imbalance, an energy imbalance, which would provide complete energy for free and carbon free and everything else. It has a bit of a third act problem, but I think it's a really interesting book in terms of something that's unexpected, a story that actually leaves you there going, wow, that's unexpected. Fahrenheit 451, absolute classic, technology used to control by design, so things like an AI influence. One of the characters is having entire relationships with avatars rather than thinking or anything else. And then the last one I'm just going to touch on just here, you may not have heard of. It's by E.M. Forster, and it was written in 1909. It's called The Machine Stops, and is scarily relevant to exactly what we're all going through now. So this is an imagination of a world in which there is remember this was 1909, in which a computer and information network now exists across the entire world, so much so that nobody goes out anymore. So everybody is in their own apartment and they have everything delivered. They shop online, they deliver papers online, all science is done online. And so they are all just in their own little bubbles, in their own little worlds, dependent utterly on this computer, this machine that is controlling the world. And it won't give too much away, given the title of it, to say this imagines what happens when that machine stops working. So strangely, it's a very short novella. You'll be done reading it in an hour and a half, and very interesting one if you look at it through the lens of when it was written. So I'm going to have a talk about robots and AI. And if we were together in a big lecture theatre, I would say, which writer coined the term robot? Now, if any of you shouted Isaac Asimov out, that's when I would do a QI thing, and this would be going whoop, 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 because a lot of people do think it was Isaac Asimov. However, I am sure some of you have shouted out the correct answer, which is Karel Čapek. And he wrote it was actually a play called Rossum's Universal Robots. There's a shot from the original production of it. And in this, the robots were organically grown androids. It was Asimov, amongst others, who adapted the idea to inorganic robots. So you could say that Asimov and a few others were the first ones to say, let's have these metal and plastic robots. But the original ones, including the use of the word robot, was invented by Čapek. In Czech, robota means forced labor, of the kind that serfs had to perform on their master's lands, and is derived from rab, meaning slave. So that's where it came from. And in that, the robots get fed up of being treated that way and stage a robotic coup. So the first of the Asimov stories in which there were 3 laws was one called Runaround, which was iRobot, even though you may have seen a film with Will Smith in it, is actually a collection of stories. It's not a single story. And he was very reticent about his positronic brain and how it actually works. And the story that I've heard, that I've looked at, is that when the first of the robot stories were being written in 1939 and 1940, the positron was a newly discovered particle, and his publisher suggested that it would give a boost of popular science to the stories. Having then written a load of stuff about positronic brains, he was kind of locked in from that point onwards and just had to stick to them. Now, I have to cover this just in case there is anybody out there who has not heard of the 3 laws of robotics, but it is used so much that pretty much anybody who writes about robots since then has to decide whether they are living in a 3 laws universe or not a 3 laws universe. So a robot may not injure a human or through inaction allow a human being to come to harm. A robot must obey the laws given it by humans except where such orders conflict with the first law. And a robot must protect its own existence as long as that doesn't conflict with the first or second laws. And these were so fascinating and so interesting that he basically got about 30 books out of this, or 30 books and short stories, just exploring this concept. Because of course we all worry that AI, robotics, is going to take over and make us all obsolete as human beings. Now, in my second book, Under the Shell, there is a robot, and there are 2 categories. So one have basic ordinary processors, like you or I would expect. I've decided they're probably using graphene now because we have 3D circuits, and I imagine things that are only 1 atom thick enables you to cram even more layers into these 3D circuits, chip layering, to compress and miniaturize the processors. But then I also imagine this other thing called nanometronic. So this is, again, building on the kind of thing that Asimov is talking about, where you grow neural networks. And this kind of thing, you couldn't really program, they have to learn. And there's a lot of fascinating information out there about how machine learning and artificial intelligence learning can happen. But one thing he never said, Asimov, was he always said you can't mess around with a positronic brain without destroying the brain in terms of those 3 laws, that it's so fundamentally in there that you can't change it. And so I had to think about that. How could that be? And I imagined that, let's say we've got this neural network of little cells, but let's say there's a processing unit inside each one of those cells. And that is the thing that contains the information saying, do not kill human beings. And that way it's in every single one of these cells. Unfortunately, in this book, somebody takes out that little inhibitor and suddenly there are robots running around without the 3 laws, but that's another basically a plot device, and one that I enjoy playing around with. So robots and AI, there's a couple of big ones in recent years where AI is a fundamental character within the story. Ian M. Banks produced an entire series called the one that I first read, the one where I first accessed it, was The Player of Games. But this is in a universe called the Culture Universe, where artificial intelligences are every bit as valid as human beings and every other alien species that's in the galaxy, and they are living with us and amongst us on an equal terms. In Ancillary Justice, the artificial intelligences are ships, essentially, and so these ships have control of various different functions, including semi-biological things called ancillaries. So they're all part of this greater organism. But again, that's there as well. And then some books have fully rejected science and artificial intelligence. I'll put a couple of examples here. One is by a friend of mine called Rob Duncan, called The Bullet Catcher's Daughter. He is created an alternative world where science is now curtailed by something called the Patent Office, where they're trying to prevent further machines of war coming about. So anything that is new, any new science has to be approved by them and made sure that nobody will be able to use it for war. And interestingly, in Dune, I hope you've heard of Dune, it's the enormous, well, it was originally a trilogy, it got bigger and bigger. In my personal opinion, the first one, Dune, is the only one really worth reading. The others just get weirder and weirder. But in that, they make multiple references to a time previous to the book where artificial intelligence had basically taken over and enslaved humans. And so they don't use it anymore. And they create these people called mentats, who are human living computers. Fun fact on The Bullet Catcher's Daughter, on page 227, there is a creepy Victorian doll named after me. David the Doll, who would do that? Anyway, so I'm going to talk for a moment about anthropological physics. Yes, I did just make that up, and I've had the temerity to put it next to a couple of Asimov books as well. So I have a character called Daruna Chandramogan. She's a professor of anthropological physics. What on earth does that mean? Well, physics, by its very nature, is universal. We're used to chucking constants around. We love a good universal constant. We make assumptions based on them. X is proportional to Y once we stick a constant in it. But we have to be careful about the difference between numeric constants and ones that are just assumptions. Now, I'm going to talk for a moment about the end of Foundation and Earth. So in Foundation, humans are treated, there are so many humans now that if you treat them like atoms, you can now make predictions about the sheer number of human beings. And although you can't predict what an individual human will do, you will be able to predict what humanity as a mass will do. And I have to be very careful with spoilers here with what I'm about to say, because what I'm referring to is the last 3 pages of the 5th chronological final book of the Foundation saga. So you have to get through about 5 books in order to get to this point. And the character must choose between a second Foundation and an alternative that's called Gaia. And it's only when he realizes that one of the assumptions we all make, and one of the assumptions that's been there through all 5 books, is incorrect, that he can make that decision. Now, what I'm talking about with anthropological physics is that the physics of the universe may not be different no matter where you are in it, but the path that an alien species could take to get to that physics could be very different indeed. So let's imagine human beings in comparison to an underwater civilization. Okay, and who I have up here at the moment is a guy called André Kuipers, who was a Dutch guy who went onto the European Space Station, International Space Station, sorry, as a European astronaut. And as part of that, they did a classroom thing, which involved these things here. And you can see that he's holding a device, and here is one of those devices. There was a second one as well. I'm not going to go into that one about bubbles. But what this is it's a convection experiment. So you probably can't see this very well, but there's this liquid inside here, and there's all these little points, and I have really cold hands, so this never really worked for me. But essentially, if you hold that and it heats the liquid, then the convection current will send that liquid up here, and it will start to rotate around the device. And the idea was that he did live lessons from the space station in which he's holding the same experiment as the kids on Earth, and it doesn't work for him, because there's no convection currents in space. Convection currents relies on the air expanding, becoming less dense, and thus rising up above denser air. And when you're in a zero gravity environment, that doesn't happen. So let's imagine on this underwater civilization that there's an octopus Newton. So the human Newton observed the effect of gravity with the falling apple. Now, the octopus Newton is looking at different objects, and she'll see a rock fall, but living things will float until they die, and then they will fall. So is it in the nature of living things to float and dead things to fall? And the path to gravity becomes trickier. So NASA even used flotation tanks to simulate a world in free fall. But what might they get to quicker? So human beings would watch birds on thermals and see them rising up, but they wouldn't experience the thermal for themselves. Whereas the octopus Newton can actually swim over to a thermal current and experience it. So maybe she'll get quicker to that, but maybe not so quick to gravity. Although maybe explaining the thermals will be really difficult because of that lack of gravity. So I'm not saying that it's different, but I'm saying that alien perception of physics could be a very different experience to the human experience. So let's get into communications for a moment. Now, I put up the Hitchhiker's Guide to the Galaxy because they talk about something called the sub-ether waveband. Sub-ether is an old-fashioned word dating from before the Michelson-Morley experiment. And it essentially means that you could broadcast on this medium that permeates the universe outside of the normal laws of physics, and you can have live communication through it. And of course, I'm not holding up Douglas Adams as any kind of paragon of physics, given the infinite improbability drives and the bistro math that relies upon the inconstancy of numbers within an Italian bistro restaurant in order to be able to move through the galaxy. So possibly not a great place to find physics. Wonderful books though. Please do read them if you haven't. So I'm gonna think for a moment about how communications could happen in the real universe. Especially in my books, I imagine that faster than light travel is possible, but not faster than light communication. And that made me think about something from Napoleonic times, in actual fact. So Napoleon, across his empire, wanted reasonably rapid communication, and he used these semaphore towers. So there would be a series of towers on hills that could just about see each other, and they could send messages to each other using semaphore. So there's a picture of one for real. And there's a map of the network across France. So you could send a message from down here. I believe it would take about 24 hours using this system to send a message from the Spanish border to Paris. So it just sends the message to the next tower, and they send it on to the next tower. And you could achieve the same thing orbitally, so in space, if you have this faster than light travel system. So you've got the planet here, sends a message, takes a couple of hours or whatever to get to the spaceship. The spaceship can then jump to the next environment and then send on the message. And you could achieve that kind of semaphore transmission across a space empire or something like that in the galaxy. There are other communications. Ursula K Le Guin, in a lot of her books that are set in the same kind of universe, a lot of books are about an Ansible, is this device that she's created. The Dispossessed is a very good one. Firstly, because the name of the planet kind of pops up towards the end and you see it and you go, oh, I should have seen that. Also, the principal character is a theoretical physicist, and there are not a vast number of books in the universe where the hero, pretty much an action hero, is a theoretical physicist, but he's there as well. The Word for World is Forest, and Left Hand of Darkness are also critically acclaimed books within her system and her genre as well. So they use something called the Ansible. That's based on the large mass of planets, but there are other things that people have used in books. So tachyons, which are kind of like a particle that don't obey the laws of physics. Maybe it's dark energy, maybe it's dark matter. Don't know anything about that. Quantum non-locality. So this is the and wormholes. So passage through from different points in space to different points in space. There's things like ultrawave, hyperwave, tachyon. I'm not going to go into these now. Each one of these, when I was researching this particular section, has pages and pages of explanation, scientific explanation, and so on. The one I do like, that I've read things that show that it's hokum, you couldn't do it, but it still tickles me, the idea of quantum entanglement. So the idea that if you quantum entangle two particles, and one will be up and one will be down, and if you change one, the other changes, and that this is independent of the distance between them. So you would have instant change in defiance to the speed of light or anything like that. So if you've got 8 of them, you've got an 8-bit computer essentially, that if you control from one place, will instantly change in the other place. So it's a nice little idea, but I've read a lot of material saying that it would never work. But it's science fiction, not science fact. I'm talking about whether we can get physics close to things. So I'm going to have a quick look at some weapon systems. So with my background in less lethal weaponry, I got to imagine a load of stuff there. Sound, directed energy, explosions, psychological. Not all are fictional. So I previously worked on things that involve microwave guns, ultrasonics, high intensity directed acoustics. So these are kind of like sound things that are now in use around the world. Less lethal universe, I've created things called zapper rounds that are like Taser International created something called the X-Rep gun. I ran with that for a bit. Stun grenades, puke grenades. If anybody's seen Minority Report, like 6 sticks, that you achieve the same thing with a stun grenade, a grenade. So, and then in Asimov, you get things like the ubiquitous blaster. So it's basically an atomic shredding device, very useful in a world where there's a very advanced medical techniques. It would be very useful for you to completely shred somebody so that they can't be brought back from the dead. They also had less lethal things called neuronic whips, which basically induces all of the parts of the body to go into spasm at the same time. I also I love this. I've just put this in today, actually. So on the 21st of September, King's College London came up with a bandage, inverted commas bandage, which you can put onto bones, which stimulates the growth of osteocytes, the cells that actually knit together after you've broken your bone. And I put this in because I'm so delighted to see this, because about 6 years ago, one of my characters, a doctor, actually injects something just like this. I called it an osteoprogenitor into somebody's broken leg in order to do the same thing. So it's one of those little punch the air moments as a science fiction writer, when something that you've kind of predicted comes to pass. I'm sure they've been working on it far longer than I was working on this anyway. Also, the idea of the kinetic energy weapon. Now I'm going to talk, I loved, Niven and Pornell wrote the Moten God's Eye, and I think that's one of the best alien contact books I've ever read. They also wrote Footfall, which I think is one of the worst science fiction books I've read. It has a couple of interesting things in it, and another one I'm going to come back to in a moment. But these hyper-intelligent elephants come and invade the Earth. But one thing they are going to use for their weapon is kind of given away on the front of the book. So as they enter our solar system, they pick up a couple of asteroids, and the threat that they are making against the Earth and saying you've now got to submit to us is that they're going to chuck these asteroids down at the Earth. You can do this to cause a huge amount of devastation. You can, I'm sure you've seen plenty of things like Deep Impact or something like that. So they create this devastating force that you can't defend against, and has the added bonus of not blanketing the world in a nuclear kind of winter. There would be another kind of winter, kind of like a blackout winter, but at least the entire planet wouldn't be contaminated with radiation. Weapons in space. People, we're all used to seeing in films and so on, ships shooting at each other at very close quarters. Now, space is big, it's huge, and it's very rare for, it would be very rare for ships to get anywhere near each other. Now, there's a lot of fiction which says that you'd be getting ships a long way from each other. So you'd have ships over here and ships over here, and they would aim lasers at each other over great distance. And that's true to a certain extent. You could get that, but of course, space isn't entirely empty. There is dust out there. There's like particles and so on. So that would start to degrade the lasers over too long a distance. Also, lasers are focused as well. And the further away you get from a laser, the more unfocused it is. So at the other end of weapons is shielding. So again, Niven and Pornell, the Moten God's Eye, and the sequel, The Gripping Hand. They have something called a Langston field, which is it exhibits black body radiation, so it absorbs energy and then re-radiates it back in space, but it's never really explained what that is. Now, what I did with this was I had a crack at basically explaining that. So ships create a magnetic field around themselves, and then they have a charged plasma that they can squirt out of the front of their ship, and it follows around the magnetic field around the ship, and then it gets sucked up at the back of the ship and passed through, and it goes round and round. And as you direct energy weapons at it, something like a laser, that would heat up this plasma. And so the plasma has a high thermal absorption coefficient and can also spread it out instantly around the entire plasma. So the plasma gets hotter and hotter. Now, as you suck it back into the ship, obviously you can use that energy, and so you can use that to power your systems and so on. But as the plasma gets hotter, it will get bluer, and it will eventually get so hot that you can't contain it anymore. And it's so energetic that the magnetic fields won't be able to contain it anymore. That's what I was doing with it, and I was utterly delighted when in March 2017 I saw that NASA proposed a magnetic shield to protect Mars atmosphere, and I had another one of those moments go, yay, you know, they've caught up with me. But rather than claiming it, I had a bit of a dig round on the NASA website to see how long they'd been thinking about this, and sadly for me, in 1967 their first paper was published on the plasma radiation shield concept and application to space vehicles. Now, I promise I had not heard of this, okay, but as with all science, even if you've not heard of the research, you can't claim victory if somebody got there ahead of you. So those people at NASA, you know, with all their advanced training and everything else, they beat me to it. Interestingly, in most of science fiction and most of human history, warfare has always favoured the attacker, the weapon, and it's very rare to imagine it being the defender who has the advantage. One occasion, of course, in human history is the First World War, where the defenders with machine guns had a vast advantage over the attackers who were advancing towards them. But one of the main books which really has the advantage with the defender is Dune, where people can even wear personal shields that stop projectile weapons getting at them. So within the Dune universe, they actually are back to a world of hand-to-hand combat, and that's the kind of consequence of that. Now, another kind of shielding is cloaking technology, and there's a lot of very exciting things going on at the moment. Metamaterials, reflective properties. There's light bending behavior. We are not a million miles away from a Star Trek style cloaking device. But of course, in space, you wouldn't really need one. So the ships are very far apart. So they're contacting each other by radar signature, by looking at the heat of them, engine emissions, light reflection. So if you paint your ship black, matte black, and you do all the things that people already do on this kind of like stealth bomber here, if you can prevent radar signature going back and stuff, you don't literally have to make a ship invisible for it to become essentially invisible to other spaceships. Now, I also, at one point, it's a plot device basically in my book, I want people to be able to get through a port without being spotted in a shipping container. Now, these are examples from the real world, where in our ports there are X-ray machines looking for people inside shipping containers and so on. So to get through that in my environment, you have the people inside your container, and down one side of it you have X-ray detectors, X-ray absorption devices, and when they ping off, they send all of the information through to the other side of the container, and they emit the X-rays out of the other side. So it looks to the machine like it's seeing the X-rays that are being emitted by the machine, but they're actually getting ones that are being emitted by the device itself. Now, of course, it would be suspicious to have an empty container, so you also have a computer in the middle that will project what it's supposed to be. So if it's supposed to be machine parts in the container, you can have a computer adding the machine parts to the image that's coming out of the far side of it. So we're nearly there now. I'm just going to talk about drive mechanisms before finally getting on to see or not to see. So the traditional drive mechanism for going into space is, of course, our chemical reaction, basically a controlled explosion that you point in one direction and then you head off in the other direction. Now, a drive mechanism we are galloping towards now, and one that NASA absolutely and space engineers absolutely love, is the Ion Drive. So in this one, you can see that electrons, they're the ones shown in yellow, are emitted by a discharge hollow cathode. They traverse the discharge chamber and are collected by the anode wall. So the cathode's the negative part and the anode's the positive part. And then the propellant comes out and is ejected and travels towards the discharge cathode. The electrons that are moving already hit the propellant and the ions and make those ions, turn them into ions, they charge them. And at that point, there's a big magnetic field, and so these charged ions then fly out of the back of the device. Now, obviously, they're not throwing out very much energy. It would take a long time to get up to speed. But chemical engine efficiency is 35%, whereas ion drives are about 90% efficient. And if you take long enough with these thrusters, you can reach 90,000 meters per second. That's about 200,000 miles per hour. And in comparison, the shuttle goes at about 18,000 miles per hour. So the trade-off is thrust versus acceleration. So ion thrusters can provide about half a Newton of thrust, which is about the equivalent of you holding a 10 peak points in your hand. And these thrusters must operate in a vacuum as well in order to operate at these power levels. So this is something we can strap to the side of things we are sending to Mars. So Elon Musk wants to send a whole shed load of stuff to Mars to land there before the humans get there. And you can send all this stuff with ion drives and get there very quickly. Sorry, we'll get there slowly, but very efficiently. Now, these are used in Spaceship Medic, and there's a discussion of nuclear energy versus reaction mass that we were talking about there. And another thing, if you're using something like this, is your fuel supply. So if you can use hydrogen as your fuel supply for this, there's actually hydrogen in space. And so some people have imagined a big scoop on the front of your ship. I'm sorry to go back into TV, but Red Dwarf, you've probably seen that enormous big net on the front of Red Dwarf. That is sucking in the hydrogen that it can then send back to the engine to use as reaction mass and for the drive mechanism. The drive mechanism, there's one in the Mote in God's Eye, which is a solar sail. So this is one that uses, you could use the solar wind. So you have an enormous, absolutely enormous sail made out of a thin metallic substance, and that could collect the solar wind, which is a whole load of charged particles and coming out of the sun. You could even use actual light itself, the pressure created by light on a material that was observed in the photoelectric effect. So you could actually build one of these things, and if you had really high power lasers, you could actually use lasers to push the entire thing forward as well. The drive mechanism, again, I said I'd come back to football because it's the only place I've ever found something called an Orion Drive. Now, this was actually a program by the Americans back in the 1960s, and this is to actually power a spaceship by dropping atomic bombs out of the back of it. So you would shoot an atomic bomb out of the back, that would explode, and then thrust against this, the explosion itself would thrust against that drive plate and push the spaceship forwards. The main thing that killed that as an idea is that the amount of radiation created by one launch would be enough to kill 3 people globally. And it doesn't sound like that many in a population of 7 billion or so on. But if you said in order to launch a spaceship, you had to shoot 3 people in the head, that would not be, quite rightly, would not be acceptable. And so that's what essentially killed the Orion mechanism in the end. There are other drive mechanisms in Revelation Space by Alistair Reynolds. There's a whole thing about reaching back in time to collect energy from the start of the universe. But it's interesting, he is in the world, along with Ursula K Le Guin, where people do not go faster than the speed of light when they're traveling. This has all kinds of results when you are writing a story. Some of them, for example, is about the experience of traveling through space. So especially in both of these worlds, Ursula K Le Guin and Alistair Reynolds' worlds, people who live and work in space are on a different timeline to everyone else. They live longer, they go into deep sleep. And also, there is something called time dilation. Now, I'm sure a lot of you have heard of this. When you approach the speed of light, weird things happen to time and mass and height. So a ship, let's say that's accelerating at 1G. You remember earlier I was talking about ships that accelerate at 1G, you experience 1G. In 1 year of accelerating at 1G, that ship would reach 0.77 times the speed of light. And the time that would elapse on Earth due to this time dilation effect is about 1.2 years. And they'll have traveled about half a light year in that time, which sounds, you know, if you could get an energy supply which allowed you to go at 1G, that starts to sound like a normal amount of time to get somewhere like Alpha Centauri, which is about 4 light years away. So you could get there in a human expanse of time. After 2 years of acceleration, you'd reach 0.97 times the speed of light. But the time, as far as Earth is concerned, it's actually taking you 3.75 years So although you've only experienced 2 years on the ship, in the universe, in the static universe, nearly 4 years of time has gone past. And you've traveled about 3 light years over that time. In 5 years, you'd be reaching this amount, the speed of light. But the time elapsed on Earth in the 5 years that you've had on the ship, that's 83.7 years. So at that point, if you are a space person who travels around on spaceships, your family's gone. You know, this is beyond the human life, that you have already divorced yourself from the humanity back on Earth. Interestingly, if your mass could be weighed by somebody on Earth, you appear to be 6 tons and 25 centimeters tall, but we'll leave that to one side. That's irrelevant. The point is that you've now traveled about 80 light years of distance. In 8 years, you're getting faster and faster, but in 8 years, you're now at 1800 years on Earth. And 12 years is about the time it will take you to get across the galaxy. But by this time, 113,000 years have passed on Earth. Now, obviously, if you're traveling somewhere, about halfway, you have to flip over and spend the second half of the time slowing down. But even so, you can see that in this kind of universe, which is the real universe, as far as I'm not claiming that faster than light travel is actually possible, this is the kind of experience you would be having as a spacefaring people. So there are plenty that allow faster than light travel. So Asimov, people jump from place to place, but it's never really explained. Silverberg in Collision Course has something called Transmats. So you have to take these devices to each location you want to go at sublight travels, and then once it's set up, it's like a teleportation device from one place to the other. In Dune, the navigators fold space. Niven and Pornell talk about tramlines at jump points, so points of some kind of constant energy between 2 places in the universe. What I choose to do, everybody's got to come up with their own version of doing it, and what I chose to do, so we have a gravity well here created by a large heavenly body, and obviously at some point the rate of change in the gravity field experienced by an object is at its maximum rate of change. And I've imagined that at that point space-time becomes unstable. And so what happens with my ships is that they fire little miniature black holes, little hawking black holes at that position, and it makes it unstable and tears open a hole in space-time that they can pass through, essentially creating a wormhole to the new location. So how do you do that on a ship? Well, the ships of my future all have particle accelerators in. Now, I know that CERN is like 20 miles across or whatever it is, but everything in the world has always been miniaturized. So I imagine that you can get these particle accelerators down to a ship-sized object. So you've got your particle accelerator, the things going around it, crashing into each other just here, creating these black holes that you can then shoot out of the front of your ship and tear open these points in space. And it's interesting, so you've got these particle accelerators, so you can also use them to power your ship, to use instead of an ion drive, so that can thrust your ship forwards as well. So you've got these great big ships with these accelerators in and doing both of these things. Now let's imagine, again, I don't have faster than light communication, so let's imagine that we actually want, and from the 18th century, they had these things called sloops, which were little ships that were super fast, and their whole point was to go backwards and forwards, taking messages around the place. And let's imagine that that is all the space you need to maintain a small crew. So that's all of your life support mechanism and everything else. Now, if you wanted a sloop, that's all you'd need in terms of space, but you still need a great big particle accelerator in order to be able to achieve the faster than light travel. So you have your bit in the middle, and you can connect it using metal, using skin or whatever, to this thing around the outside. And of course, you don't need your actual living space to be square. You could make it round. And as I was thinking of this, I was actually standing in the shower when it came to me that I am as bad as all of those pulp science fiction writers that I was talking about at the start. Because what I have essentially done there is reinvent the flying saucer. But at least I've come up with an explanation for it. And that's probably where I'm going to leave it for now. So I hope you enjoyed that whistle-stop tour through my bookshelves and what I think about physics in there. And I'll be happy to take any questions that anyone has.
Wonderful. Thank you, David. There's certainly a huge amount of physics in lots and lots of different novels that I was previously unaware of. So I'll be checking out some of those books. We actually already have a question that's come in, so I'll just go straight to that. So this question is from Olivia. So what area of physics would you like to see explored in sci-fi novels which hasn't been so far?
It's an interesting one. I've met somebody who says that AI is not covered. It should be in any future book, and it's certainly the case that we have books where AI is present, and we have books where AI is fought against. But as far as I'm concerned, apart from very far future novels, we've not really experienced any science fiction where AI is living with us. I was reading a book by Tamandra Harkness recently, Radio 4 person and so on. She wrote it about big data. Oh, I've left it upstairs. Big data book. And in that, she's talking about something that a lot of Americans have come up with, which is the idea of a singularity. So singularity has multiple different things in different definitions according to which bit of science you're in. But this idea that there is a single artificial intelligence, and maybe it's already with us. Maybe it has decided that human beings are very good for it, and so it creates a world in which all these people go to Silicon Valley and feed it and look after it and make sure that it's better and so on. And I would love to see a book which explores the emergence of real artificial intelligence as a benign force rather than all of the kind of like bad things that happen, and how we can live with that. And because we're talking about artificial intelligence as the moment as kind of like big data and looking at objects and things like that, I'm interested in that real actual intelligence, self-awareness, thinking device that is not going to try and kill us. And it'd be nice to actually see somebody get into that.
Oh, great. We've got two questions that have just flown in. The first one from Anna. Have you read the Honor Harrington series? And if so, what did you think of the physics in that?
I'm afraid I have not read the Honor Harrington series.
Okay, that's a nice easy one.
Comment on that. Very sorry, Anna.
So then on to John's question. So great talk, David. Many thanks. Pleased by your mention of the machine stops. I studied it in 1963 and loved it. How about Dyson spheres or ring structures, as in Nevin's ring world? Any credibility? Might they appear in your future works?
Okay, so forgive me if I'm wrong, and please just send a question through again if I'm getting this wrong. So a Dyson sphere is something where you actually create an entire solar array that collects all of the energy from the sun. I hope that's correct. Or at least some significant proportion of it. If I've got that wrong, I do apologize.
Yeah, it says that's all right.
Yeah, okay. I put that one in with space elevators in terms of, yes, physically possible. Could we achieve it? Probably not, due to lack of resources, human intransigence. It's kind of a Tower of Babel kind of situation. It'd be great to really good to kind of sort it out, but I fear that humanity could never really get its act together to do it properly.
Another one coming from Anna. So what do you think of Elon Musk's idea to link humanity to AI?
I think, yeah, I personally, morally, I have no problem with it. I possibly wouldn't do it myself because I don't like the idea of being hacked. You know, if you plug yourself into a machine matrix, then you are exposing yourself certainly to more things. I also wouldn't want to rely. I'm kind of old-fashioned in that I do like the ability to walk around even if the power goes off. You know, so obviously Elon Musk is talking about stuff that is bio powered, I'm sure, or that, you know, you've got an uplink, a personal uplink to the cloud or something like that. The wonderful bit would be learning foreign languages. That would be absolutely brilliant. You just buy your upgrade. But then that's the thing, isn't it? This is a billionaire who can buy anything he wants. I cannot imagine some kind of altruistic world where everybody gets to just log into anything. And so I think the biggest worry about linking humans to AI is you are creating an entire new class system, class structure, haves and have-nots at an even more fundamental level. It may be something like, again, sorry, I'm going into a film again, Gattaca. So that's in a world where people do designer babies to whatever level, but it's according to what they can afford. And so, yeah, it'd be fantastic for some of us to be able to network with AI and stuff like that. But I am just concerned that in a corporate profit-driven world, that it's like if immortality came to exist, only the super rich would ever benefit from it. And I can't help thinking that only the rich would benefit from Mr. Musk's imagined future.
Yeah, so just a comment to add on there that's just coming from John. So the Astronomer Royal likes the idea of space exploration by AI-assisted humans. Apparently that's been said at a talk at Surrey Uni previously.
Yes, I've been on a stage with it's Lord Rees, isn't it? I believe we're talking about. He's not happy with he would rather the amount of money we spent sending humans into space was spent in exploring space. And I know that's something he feels very passionately about.
Yeah. So a question then from me. So when you were sitting down to start writing your novels originally, sort of how did you, there's obviously loads of different themes that you could have explored, and why did you go for the themes that you picked? Sort of, was it easy? Was it quite obvious to go down the route you did?
The human story is where I started. So this character and the things that happen to him and the women that he meets and the men that he meets on the way and everything like that's the meat and bones of the story. Everything else that goes on is because I'm a physicist and I can't bear for it to be unexplained. Now, I hope, and I've been told I've succeeded in never bringing all this clunky science to the front. It's never been a book about the science. But whenever anything happens, or wherever he goes, or whatever piece of technology, there's a battle in there, and all these things, I had to make sure that that was physically acceptable. It's not right, but at least adjacent to real world physics. So yes, the story, the human story, is what I was actually writing. But the rest of it, the themes that go around that, the AI, the technology, the weapons and everything else like that, is just stuff that I needed to have personally to make my world work. And leaving it out was really difficult as well. So I figured out how an object works. I know exactly how it works, but that's utterly irrelevant to the story, and nobody reading it actually wants to know that. So maybe I'll start a blog and put it all on there for all the nerdy people like me who really want to know how everything works.
Yeah, your own online fan club.
Yeah, that'd be great.
Okay, so another question from Anna. So the Fermi paradox is often ignored in science fiction. Did you consider its ramifications in your books, assuming you have aliens in yours? Do you think we are ahead of the Great Filter or are yet to meet it?
I'm not sure I understood all the parts of that question. I'm certainly, yeah, I've not got to it yet in my book, so it's a bit of a trailer of what's coming ahead. I think if we assume that spacefaring is a thing that people can achieve and which aliens can achieve, I think whichever species gets to it first becomes the dominant species in that part of the galaxy. So in Star Trek, you have the Prime Directive where people won't interfere with alien species that haven't reached faster than light travel yet. I don't think that would happen in reality. I think the competitive urge of, or certainly what I have in my books, is that the competitive urge of a species is that they wish to dominate. And so the first species to get into space and start interstellar space travel may not wipe out all the other aliens, that I think they will dominate. And so I think the fact that we've not been in contact by them means that nobody's got there before us yet. I do believe there is life on other planets, and the latest iterations of the equation calculating how many ones there are out there. I saw it was about 4 weeks ago, I think it came out. The latest calculation is there are 36 intelligent civilizations in the galaxy, or something like that, that we haven't encountered yet. I don't think anyone's ahead of us. And I'm saying all that thinking I understand what you mean by the Fermi paradox. I may have completely missed the point entirely.
So another question from Anna: where did the 36 come from?
Oh, that one. It's from the. Hold on, just let me look this up. There's an equation. Drake equation, the Drake equation. If you look that up, you'll find it certainly in Wikipedia and so on. The refinement is that, so it's an equation that looks at various different things. It's at the SETI Institute and stuff like that. And it looks at the rate of star formation in our galaxy, fraction that have planets, the average number of planets that can support life per star, so the ones that are in that Goldilocks zone around the planets. The ones that could actually develop life at some point, the planets where life actually does go on and then develops intelligent life, and so on and so on, and all these things build up. And the thing we're finding out more. 20 years ago, when I was at university, we hadn't seen any exoplanets whatsoever. We weren't even sure that the accretion disk was the way that planets formed. There was a catastrophic idea that was also, you know, that something came into the accretion disk and actually created the planets. And we've now found over 4,000 exoplanets, and these things are, and we're figuring out how many are in the Goldilocks zone, and we're figuring this out. So every few years, some scientists get hold of the Drake equation and do a whole new set of calculations to it. And the one that I saw, it was a few weeks ago. I can't remember exactly who did it recently. It was in Physics World, Institute of Physics, Physics World, or on our website or something. But yeah, it came out that the latest estimate is 36 civilizations using that refinement of that Drake equation.
Okay, so a question now from another Anna. Do you think sci-fi writers have a responsibility to write about physics accurately?
Going to be really controversial. No. I think they have to be clear about it. I do think if you're gonna, I think you shouldn't write pseudo-scientifically. I don't think you should do things that are blatantly wrong. An example, apologies to anybody who doesn't believe in vaccines, but somebody who wrote a serious piece about how vaccines are actually don't work and all the rest of it. It's the same with physics. I think if you create some kind of physics universe that is fundamentally really wrong, and then present it as actual fact, not that you got it a bit wrong, or that you're putting yourself ahead of physics or next to physics, or even to create an alternative physics universe in which you clearly say, in number one, there's a famous opening line, I can't remember exactly what it is, I'm going to paraphrase it, that on Monday morning John woke up as a dog, and that has created a universe in which you will believe now that John is a dog. Okay. But in science fiction, especially for stuff that you're giving to children or something like that, I think you can be a bit wrong. You can go beyond, you can go next to, or something like that. But if your intention is to set out and propagate incorrect science, then I think that's where you start to morally fall down.
Mm-hmm. So something that I was thinking when you were showing all the different books, quite a number of books throughout your talk, I was wondering, seeing as we've been stuck at home for quite some time now, what are you currently reading, or do you have anything planned to read next?
So I'm currently reading Big Data by Tamandra Harkness, which is actually not fiction at all. I have just finished reading The Mirror and the Light just before that, which I'm big into Elizabethan stuff. And I've got something new, actually. I've forgotten what it's called. It's upstairs at the moment. It's a murder mystery set in the Great Fire of London. So you may be expecting me to say that I'm reading science fiction all the time. I don't, because I go stealing ideas out of other things, noir books and stuff like that. Oh yes, and also Grossman's Life and Fate. He has a sequel that's another 900 odd pages called Stalingrad that my sister has bought me for my birthday. But she says it's too big for her to put in the post, so I'm just waiting for her to see me again so that she can hand that over. And that'll take me about 6 months to get through, I'm sure.
Brilliant. So while we just wait for a couple more questions to come in, I just wanted to remind everyone that this is a live event organised as part of the Institute of Physics South Central Branch World Space Week set of activities. And tomorrow we've got another live event which is taking place same time in the evening, which is a quiz, a space-themed quiz. So something slightly more light-hearted for a Friday evening. We'll be giving away some great prizes for the first, second, and third places, and also for the most inventive team name as well. So we're giving away things like a Earth and constellation globe and some lights and things. So so do check that out tomorrow evening. And all the details for that will be on our social media pages. So Institute of Physics South Central Branch or IOPSCB on Facebook. So have a look at that. So while I was doing that, quick reminder, another question came in from John. So quite a few sci-fi books revolve around the concept of telekinesis and other forms of ESP. Have there been any physics experiments that have hinted at this concept actually being possible?
Interesting. So in my old job, so it was in forensics essentially. One of the perennial problems we had was to find dead bodies. So if we're looking for somebody who we think may have been murdered, we want to go and find them. And some of these bodies are old and so on. And we had a lot of people who would come to our facility and say, I have a method for finding dead bodies. And some of them were electronic devices. We tried out foxes for a while because they have a very good sense of smell and so on. And so whenever any one of these people turned up, on our site were pigs, buried, dead pigs that had been put down there like 20 years earlier. And they were in different locations around the site. And one was under a tree, and one was under the car park, and one was under the ground in other places, and so on. And so whenever anybody turned up with, I got a guaranteed way of finding dead bodies, we say, right, have at it. There are dead bodies on this site, go and find them. And one person who turned up with ESP. It was slightly before my time, so I wasn't there, but they turned up. I'm not sure whether it was with cards or some other thing. And so they came on site and tried to use their ESP to find these bodies and failed utterly. So that's the one that I've encountered that's to do with it. I'm sure there are others out there, but that's an example from facility in my own life. Where it was an interesting job because people came up with all kinds of things. There was the Czech Republic came up with a gun that fired tennis balls. That was an entertaining day on the firing range. We'd fire these balls down and then they'd bounce back at us and we'd have to hide and stuff. So. But yes, so my own personal encounter with ESP is it didn't work. I'm sure there are others out there.
Okay, so I don't think any more questions are coming. Oh no, wait, just as I said that, one more's come in. So we'll do this last one, and then we'll wrap up for today. So have you read any H.G. Wells, and what is your opinion of him?
Yes, I read The Time Machine. Interesting fact. I think it's the first ever fictionalization of traveling forward in time. An actual time traveling machine, The Time Machine by H.G. Wells. It was very interesting. I enjoyed it utterly. I enjoyed War of the Worlds as well. They are of their time, but I think they stand the test as cracking good stories. The Time Machine, he doesn't attempt to explain the physics behind it or anything like that, which I appreciate. Time travel is a fictional device. Hawking had various things to say on it, and the possibility of going backwards versus forwards and all the rest of it. But H.G. Wells, yeah, really entertaining stuff. I think War of the Worlds actually stands up fairly well to scientific rigor as well. But yeah, and if you like H.G. Wells, get into Jules Verne as well. But yeah, big thumbs up. Where is it? Here we go. One of those H.G. Wells, like him.
Okay, wonderful. Well, thank you very much for your time this evening, David, and for a very interesting talk. And I will certainly go and check out a few of those books and get a bit more into science fiction writing, I think. So thanks very much.
Okay.